Hey guys, welcome back to the midterm review. In this section, I'm going to work problems 12 through 14. These are just sort of some miscellaneous equations. Chapter 1 was probably one of our most challenging chapters of the semester simply because there's so many different types of equations and methods to remember. So getting started on number 12, notice we have a one radical equation. To get rid of that radical, we are going to square both sides. So I'm going to square the left side and I'm going to square the right side. When we square the square root, those are opposite operations, so they basically cancel each other out. Be very careful over here on the right side. We don't want to distribute that exponent. Instead, we want to be very careful to FOIL out the right side. So write that binomial twice as the exponent indicates. When we FOIL, the product of our first two terms is x squared. Notice both the outside and the inside terms are 6x, and the last we have 36. Now that the radical is gone, I have a different type of equation. Observe it's a quadratic equation. We practiced solving those on the previous few problems. To solve a quadratic equation, our goal should be to get it equal to 0. So what I'm going to do here, I'm going to take one step just to combine like terms over here on the right side, and then our goal will be to move everything over to that right side. So this gives us x squared plus 12x plus 36. Again, I want to move everything over to the right side where that x squared term is. So we're going to subtract 2x from both sides, being careful to combine like terms. And we're going to subtract the constant 15 from both sides, again placing that with the corresponding constant. This gives us the 0 we were aiming for on the left side, and our new quadratic equation is x squared plus 10x plus 21. At this point, you can solve it by factoring. You can use the quadratic formula if you wish. The method is not stated, so choose your favorite method. I'm going to go ahead and go with the factoring method. That seems to be the most efficient way. Again, if you're rusty on factoring, you can certainly use quadratic formula. Go the route that you feel most comfortable with. So in this case, I'm looking for two factors of 21 that have a sum of 10. That would be 3 and 7. Now, if that factoring seems like magic to you, go back to the review chapter in your textbook, read over those methods, and practice a little. Once we have our two factors set equal to 0, we're going to be able to solve our equation. The first one clearly gives us a -3, and the second one a -7. But wait a minute, Miss Cornell, there's only one answer listed in the answer list. Only x equals -3 is the correct solution. We did all the algebra right. However, we have arrived at something called an extraneous solution. Anytime you have a radical equation, it's very important that you go back and check both of your answers in the original equation. So going back to the original equation, let me erase some of these details here. I want to check both x equals -3 and x equals -7 by substitution in the original equation. So on the left side, notice we have square root of 2x plus 15. I'm simply going to type that into my calculator and let it do all the work. So we have the square root of 2 times -3. Now, make sure that you use this little negative button in the bottom, not the minus operation. Okay? That can give you a syntax error. 2 times -3 plus 15. So the value on the left side is 3. Now, I want to check the value on the right side. So I'm also going to plug in x equals -3 to 6. Now, can we do that in our heads? -3 plus 6 would also give me +3. So I have a balanced equation. Both sides yield the value of 3. So x equals -3 is the correct answer. Now let's check -7. So I'm going to take the -7 and I'm going to plug it in here and here. Let's do the right side really quickly. -7 plus 6 would give me a negative 1 when I plug it in. Let's see what we get over here on the left side. So we have the square root of 2 times, again I'm using this little negative button, not the minus operation, plus 15. Enter. The calculator tells me it should be 1. So the left side has a value of 1, where the right side has a value of negative 1. Do you see the mismatch? So negative 7 is not a valid solution. We call this an extraneous solution. So it does come out of the algebra, but we exclude it from the solution set. The only solution there is negative 3. So it's really important that you check your answers when you're working a radical equation. You've got your handy-dandy calculator there, which can be a great help for that. All right, let's move on to problem 13. Problem 13 is called a rational exponent equation. That means there's a fraction in the exponent position. So our goal is to raise both sides to the reciprocal of that fraction. Here's what it's going to look like. I'm going to take the left side and I'm going to raise it, not multiply, right? I'm raising it to an exponent, which is the reciprocal of 3/4. So I'm going to raise the left side to the 4/3 power, and I know what I do to the left side, I have to do to the right side. On the left side, whenever I have a power to a power, I should multiply those powers. 3/4 times 4/3 is 1. That will always work out to be 1 when you use that reciprocal operation. That side's pretty easy. The right side, well, we got to work on simplifying this. If you'll remember, we have a formula for evaluating rational exponents. Here's the pattern. The denominator of that fraction becomes the index of the radical, and the numerator of that fraction is the exponent on the outside. So I'm going to take this 8 to the 4/3 and rewrite it in radical form. So we know the radicand is going to be the 8. The index of the radical is this denominator, and the numerator goes on the outside. Then we evaluate. Let's work from the inside out. The cube root of 8 is equal to 2, but I still have that outside exponent to evaluate. 2 to the 4th is 16. Now to solve, we simply subtract 6 from both sides, and we are home free. Now don't panic on those rational exponents. Remember, you do have a calculator. You can evaluate 8 raised to the 4/3 power simply by typing it into your calculator. Press enter, you've got the 16. All right, so don't panic. Remember, you can check those things with your calculator. All right, let's work one more problem for this particular video. The next one's pretty challenging. This is what we call a quadratic form equation. So we are going to solve this by the substitution method. Just FYI, if you don't like the substitution method that I demonstrate, you can multiply everything out very carefully and solve the resulting basic quadratic equation. That is A-OK. Here's a method to keep your numbers a little smaller. Notice this expression 5x plus 9 repeats. So I'm going to hide the details of that expression for a minute under a temporary variable. I'm going to call this variable u. Let u equal 5x plus 9. So I have a u here and a u here. Then I'm going to rewrite the equation in terms of u. It's going to make it look a little easier. So I have 9u squared minus 19u plus 2. Then I'm just recognizing the overall pattern of that equation. This is an ordinary little quadratic equation. We can solve this by factoring. So take some time, break it down with trial and error. You'd come up with the factorization, 9u minus 1 times u minus 2 equals 0. Then we set each factor equal to 0, and we solve for, in this case, u. So on the first equation, I'm going to add 1 to both sides and then divide by 9. So I come up with u equals 1/9. On the second one, we add 2 to both sides and we get u equals 2. Now, it feels good. We got an answer. However, that's the value of u, not the value of x. So we need to go back and use this clue to find x. If you'll remember, we said that u in the beginning represents 5x plus 9. So I'm going to take this 5x plus 9 and I'm going to replace the u. So over here I have the u. I'm going to rewrite it as 5x plus 9. Then I'll be able to solve for x. I'm going to do the same thing for this u. 5x plus 9 equals 2. Solving for x in this case, we're going to subtract 9 from both sides. So 1/9 minus 9 is negative 80 over 9. Say, what? What just happened? Well, check it out. 1/9 minus 9. Whoops. Start over. 1/9 minus 9. And then I'm going to turn the result back into a fraction by pressing Math, Fraction, and Enter. Okay? All we did there is get a common denominator and combine fractions. So we have negative 80 over 9. We're going to finish this out by dividing both sides by 5. You can think of that as multiplying by a fifth. So one of our solutions here, let's see. 5 goes into 80. Let's see. Is that 16? I believe so. So one of our solutions is negative 16 over 9. Now, if you're worried about the calculations, remember we had negative 80 over 9. If we take that, I'm simply going to press my divide button by 5, and we get our negative 16 over 9. Okay, so all those calculations, it's a great idea to double check them with your calculator. We've got one more equation to solve for x. So we're going to subtract 9 from both sides and then divide by 5. We come up with two solutions, negative 16 over 9 and negative 7/5. All right, those are pretty challenging. When we get to the inequalities on the next section, those will be a little bit easier. So pause, go get a snack, get a drink, come back, and we'll begin with 15 in the next video.